All right, so we are going to redo some more practice with solving two-step equations. And so you can see I've done the first one in the in-class practice, and I'm going to go through a couple more and then let you finish the worksheet. So let's take a look at 16 equals 19 plus k divided by 4. And so we've talked about that we want to go in the reverse order of the order of operations. Parentheses, exponents, multiplication and division go together. Addition and subtraction go together. And so we want to find out where our variable is. It's right up here. And on that side of the equation, the very first thing we want to do is undo any addition or subtraction that's going on in that equation. And so I have an addition, the plus 19. So I'm going to undo that first. And the way I'm going to undo that is I am going to subtract 19 from that side of the equation. And because it's an equation, an equal sign, sometimes I like to draw an dotted line there to kind of make sure I'm keeping balanced. I have to also subtract 19 from the left side of the equation. So over here, 19 minus 19, I undid that addition, which is what I wanted, and I'm left on this side with the entire expression k over 4, which is the same thing as k divided by 4. I have an equal sign, and I have 16 minus 19, which is a negative 3. So now that I've undone any addition and subtraction, I'm going to go and keep reversing the order of operations, and I'm going to undo any multiplication or division. And again, we're talking about of the variable. So this variable k is divided by 4, and so I would undo that division by multiplying. So I am going to multiply this side by 4, and then I'm also going to multiply the other side of the equation by 4. And so I just put that parentheses there to remind me that it's multiplied by a negative 3 here, not subtracting 3. So what happens then is my 4's cancel on the right side of the equation, and I'm left with a k equals, and 4 times a negative 3 is a negative 12. We can check our solution by putting it back into the original equation. So does 16 equal 19 plus what I found for k, negative 12 divided by 4? Well, negative 12 divided by 4 is negative 3. So does 16 equal 19 plus a negative 3? And it does. So that checks. My solution is correct. Let's take a look at a second example. So let's look at the 57 equals 21 minus 12k. And again, this is the variable. So the first thing I want to do is undo any addition and subtraction. So something that's tricky about this is students will see this minus 12k and they'll think that the 21 is being subtracted. But that's not really the case. The 21 is like a positive 21, and it's the same as plus a negative 12k. And so really, because the sign in front of 21 is positive, that is going to be undone by subtraction. So I am going to subtract that 21 from the side of the equation. And then I am going to make sure I also do it to the other side of the equation to keep it balanced. So I simplify, 21 minus 21 is 0, so we undid that addition of 21, and what we're left with, be careful on this side, is a negative 12k. And that means a negative 12 times k. We have an equal sign, and then on the left side of the equation, we have 57 minus 21. And 57 minus 21 is 36. So my second step is we're going to undo any multiplication or division. And this is a negative 12 times k, so multiplied by k. So even though we have a negative sign, which can be confused with a subtraction sign, what operation it is doing to the variable is actually multiplication. So the way that I undo multiplication is I am going to divide. So I'm going to divide both sides of my equation by a negative 12. That's going to cancel. The negative 12 divided by negative 12 is 1, or 1k. Just leave it as k. And 36 divided by negative 12 is negative 3. And once again, I've left a lot of room here to check your answer. So if you want to check it, it would say 57 equals 21 minus 12k, or plus a negative 12k. I put my solution in. A negative 12 times a negative 3 is a positive 36. And does 36 plus 21 equal 57? And yes, it does. All right, so going down to the bottom here, if I give you choices about what a solution is, what you could do is you could just plug those numbers in to check and make sure. And so as I'm plugging numbers in, I would plug them in for y. And so if I'm showing you how to do that, let's say I wanted to use a calculator to do that, which you may use. So I'm going to grab my calculator here. It's a graphing calculator, but you don't need to have a graphing calculator. You can just have any old calculator you want, or use the app on your phone. If I wanted to see if these were solutions, I could plug them in for y, and I could just use the keys on my calculator to help me with that. So minus 5, I'm going to plug the very first one in, negative 8.6, and I'm going to see, does that equal 34? And I see that it does. Okay, so negative 9 minus 5 times a negative 8.6 does equal 34. It made the equation true. So since it made it true, A is a solution. Now let's see if any of the other ones make it true, so you can see why the other ones would not be solutions. So if I plugged in 5, for instance, I would have negative 9 minus 5 times a 5 that I'm putting in for y. And we see that that equals negative 34. So negative 34 is not positive 34, so therefore that one is not a solution. Watch when I plug in a negative 5, what happens? So negative 9 minus 5 times a negative 5, I get 16, not 34. So that is also not a solution. And I'll plug in the last one, negative 9 minus 5 times 6.8. I get negative 43. And so this is just showing you how if it's a multiple choice question, which at some point you're going to take the PSAT, and let's say maybe you forgot or you were unsure of the steps to solve an equation, you can just put those numbers in for the variable and see if it makes the equation true. And so that's what I would like you to do on the remaining 2 problems of the in-class practice.